So we'll be answering exam questions on vectors in physics. Question number one, a displacement d of 100 meters from the origin at an angle of 37 degrees above the x-axis is the resultant of three successive displacements d1, d2, and d3. We don't know d3, that's the one that we want to find. That's our question. So how can we go about this question? Every time you're working with vectors, the easiest to be able to answer questions is for you to be able to see how it is going to appear on the number line, the x or y plane. So I'm writing the x or y plane here. And we have been taught that we have got, remember when you have got vectors, when you add the vectors, what you are going to get at the end of it all is what we call the resultant of a vector. So here they've told us that d is the displacement d is actually the result after we move, okay, after we add the three displacements. So maybe let's say I started from this point. They tell me that I went north. North is going forward. They tell me I went east. East is going in this direction. They tell me I went south. South is this direction. Where are you now? So at the point where you are, if you add vector number one, number two, number three, it will give you the point where you are. So that's the same way with this question. So let's put the data that we have. So we've been told that vector d, which is the resultant, is 100 meters from the origin. If we say from the origin, we mean from the positive x-axis. And every time we are moving in vectors, we always move in the anti-clockwise direction. We go like this for vectors. Please note this, okay? Unless they've told you that you have gone in the clockwise direction, otherwise you go in the anti-clockwise direction. So vector d is 100 meters from the origin at an angle of 37. Look at this, angle 37 above the x-axis. So this is the x-axis, make an angle of 37 above it. So it's going to be like this, something like this. So this is the angle 37. This is vector d, okay, and that's a resultant, that's capital D. And then we go to the other vectors. D1 is 100 meters along the negative x. Can you get the English there? It is along the negative x. Negative x axis is this one. So it is along the negative x, meaning that we are all vectors start from 0, 0, and we are moving along the negative x. This is the one, but I've written it badly there. This is the one going like this along the negative x. Okay, that is vector what? I can put an arrow. That's vector d1. They've told that what is the displacement? It is what? 100 meters. How about this other one, vector d? The displacement was also 100 from the question D here. And then D2, they've told us that it is 200 meters at an angle of 150 above the x-axis. So you need to find the angle of 150 above the x-axis. Now, please, it's not like you come with a protractor, you start measuring the angle. No. You know that this is 0 degrees. This is 90 degrees. This is 180 degrees. Obviously, 150 is going to be between 90 and 180. It's just you just want to show in which quadrant is the vector going to be. You're not interested in, no, this is the exact angle. Please, this is not construction in mathematics. So this is vector what? D2. And this displacement is 200. And the angle, so the angle from here up to here is what? Is 150. Is this okay so far? Is this okay? Okay, good. Please let's respond so that I know I am asking. I can easily just solve alone and I'm not interested in you getting, but I want you to understand Because trust me, you know the way these questions come. This question, if it came in the exam, the least it can be is 6 marks. Normally they give them 10 marks or 12 marks. This same question, you are going to see this same question, 12 marks. So that's why you need to understand it. So after I do this, but I don't know D3, I don't know where it is found. I don't know. I told you that the angle is known as the direction of a vector. So if I ask you to say find D3, you want to find a vector, and by definition a vector should have both magnitude and direction. So we need to find the magnitude of this vector and the direction. Actually, since this is a tutorial sheet, they've also given us answers there. So you just want to confirm these answers. Okay. So the way you are going to answer to find this vector D3 is, for every vector you should deal with, first you are going to write vector, at least because you have learned from me. This is what you should do when you're answering. All right. You write vector. For each vector, you are going to break it into components. So you are going to write the x component for that vector and the y component for that vector. It will be very easy if you are going to do this, trust me, friends. So let's start with vector number 1. The first vector that we are dealing with here is d1. I'm going to write it here, d1. Remember earlier on, what did we say? How do you find x component of a vector? So the x component, I can simply say d1 with x. That's the x component of d1. Is given by, you are going to get the magnitude of d1. Earlier on, I told you it's the resultant. I can also put r there. So it's d1. I x component is always cosine the angle. And then y component, we're going to say d1y is equal to d1, which is the resultant, but you take the sine of the angle. So let's go. D1, where is D1? Is this one. What is the magnitude? Anyone that can tell us the magnitude? Magnitude is these numbers, like how, okay? So that is going to be 100. And then cos, the angle. Now angles, I said you always measure them from the positive x-axis. So it's starting from here, going like this. What angle is this? What angle is that? Anyone? Very good, 180 degrees. Okay. So all you do is get your calculator, you write 100 cos 180. 100 cos 180. You are going to find it to give you negative 100 because cosine of 180 is negative 1. That's the same way you're going to do this side. You're going to say 100 sine 180. And that is going to give you, now sine of 180 is 0. So 100 times 0 is 0. This should make sense. Why? Why should it? Actually, this is supposed to be like this. Okay, that's okay. This should make sense. Look at the vector that we have written. This vector is on the negative x-axis. So the answer should be negative for the x value. But why? Because this is on the x-axis. Y should be 0 because all values on the x-axis are only x values. You don't have the y value there. Okay? So that is vector d1. We are going to go to vector d2. We also break it into components. It's the same. We're going to find d2x. Since I've already written the formula on top, I'll just say d2x is given by the magnitude of d2. D2, you can see that is 200. And then cosine the angle. The angle, we said that is 150. So me have a calculator, I'll punch 200 cosine of 150. And that has given me negative 173.205. And then I'm going to go to d2y, which is 200 sine of the angle is 150. So I'll simply say 200 sine 150. That has given me 100. You need to also ask yourself, do these answers make sense? If you see this angle, this vector is in the second quadrant. In the second quadrant, y is positive, x is negative. Does this make sense? Yes, because we have got negative 173 and positive 100 for y. Please, it should make sense, all right? It should make sense. If you don't get those, it means that maybe you have punched wrongly. And then we are going to go to D3. Now remember D3 we don't know. That's the one they have asked us to find. So I'll simply say D3x and D3y. These are the components. I don't know them. And then we are going to go to the resultant, which is D. So we'll say D. So the x component of D, that will be dx. We are going to say D itself, the magnitude is 100. So that is going to be 100. And then supposed to be cos. The angle is 37 there, if you can see the angle that we've used. So we are saying 100 cos 37. And that has given me 79.8636. And then we also find dy. It is 100 sine 37. So 100 sine 37, it has given me 60.1815. Do these answers make sense? Yes, because in the first quadrant, both x and y should be positive. Is there anyone that is left out here? Anyone that is behind? Yes, please. Okay, so let's start with the first question. How did we find D3? So D3, we didn't find it because we've not been given. I've just broken it into components. Remember, every vector should have the x component and the y component. So I've just put D3 there and I've said D3x and D3y because I don't know what the x component for D3 is and I don't know what the y component for D3 is. If I wanted, I could have just said, since I don't know the x component and the y component for D3, I could have just said, okay, let's say the x component for D3 is going to be x. The y component of D3 is going to be y. So our question now is to find the value for x and the value for y. Does that make sense? And then there was another question. Can you ask it again? I got another question. Where the 100? Which one? Oh, okay. But if you don't get it, please ask now because it might be worse as we go on, right? So, since we've been told that D is a resultant, one thing you need to know is that the way you find the resultant is for D, okay, the x component of of D, like remember D is the resultant. In other words, the meaning is that for you to get D, you are going to add D1, D2, and D3. So if you add the x component of D1 with the x component of D2 with the x component of D3, it should give you the x component of D. So therefore, we are saying that dx is equal to d1x plus d2x plus d3x. What is dx? Dx is here. It is 79.8636. That's a dx. That's x component of the resultant. This should be equal to d1x, that's negative 100. D2x, that is negative 173.205. D3x, we said that that is x. That's what we are trying to look for. So what are we going to do in this case? We are now going to add these. So I'm going to just get this. We are saying 79.8636, this number here. I'm going to take 100 the other side of the equation. So it will become positive. So it will add to that 79. So I'll take that 100. And then I'll take this negative 173. If it goes the other side, it also become positive. So it will be also plus 173.205. So therefore, if I add those three numbers, what you are going to be able to find is going to be 35, actually 353.0686. And this is going to be equal to what? X, because that's what is going to remain this side. So meaning that that is the x component of D3. And then it is the same way when you want to find the y component of d3. So what do we do? Y component of d3, we're going to say that dy, I should write it here. dy is equal to d1y plus d2y plus d3y. dy we found 60.1815. That is going to be equal to d1y is 0. You can see this number here. d2y is 100. d3y is just y. We don't know. That's the one we're trying to find. So what is going to be y then? Y, what we'll just do is we'll just take this 100 and take it the other side. So it is now going to be 60.1815. We'll remove 100, right? We'll remove 100. That is going to give us negative 39.8185. So this is the y component of d. That's the x component of d. Is there anyone that has got a question here? Any question? Now remember the equations that we gave earlier on. If you know the x component and you know the y component, you can use the Pythagoras theorem to find the resultant. The resultant of a vector is what we call the magnitude of that vector. Remember, we earlier on said that when you have got this, your x or y plane, okay, this is the x component, and then, sorry, that's not the x. This is the y component. This is the x component. I said that this is the angle, the direction of the vector. You have got the resultant. So what we're interested in finding is a resultant. The resultant of a vector is what gives us the magnitude of a vector. How do you find the resultant? You basically use the Pythagoras theorem. So r squared is equal to x squared plus y squared, if you remember from high school. Therefore, for me to find the r, I'm going to square root both sides. Okay, so therefore r is going to be the square root of x squared plus y squared. So that's what we are going to do also here. So the resultant here is D3. That's the same thing that we are calling as R. That's a resultant. So therefore, we're going to say that D3 is equal to the square root of the x component of D3, we square it, plus the y component of D3, we also square it, which is the same there, x plus x squared plus y squared. So this is going to be equal to square root. What is the x component? So we go back to the x component that we have found, 353.0686. 5, let's hope I don't miss, 353.0686. This is supposed to be squared. And then plus, get the y component. Remember the y component we found negative 39. Please put it in brackets because it's negative, negative 39.8185. And then we square this number. Okay, like that. So what you simply do is you can start with what is inside the brackets, negative 39.8185, square it, and then plus 353.0686, also square it. If you do that, you are going to find the square root of 126,242.9492, and then simply square root this number. You are going to find, if you do that, 355.3068. We can simply round it off to 355. Remember the others were in meters, so this is also going to be in meters. This is the magnitude. But remember, a vector doesn't just have magnitude, it also has direction. We said that for you to find direction, you give it by tan theta, and tan theta is given by y component over x component. So we're going to say theta is actually equal to tan inverse of y component over x component. This is what we said, remember earlier. So theta therefore is going to be equal to tan inverse. So what is the x y component? Oh, please always put y component on top, please. Y component is what? Negative 39.8185 divided by the x component, which is 353.0686. Just get this. It is easy, guys. Just press on your calculator shift and press where you see turn, and then now write negative 39.8185 divided by 353.0686. This is going to give you theta being negative 6.4345. Because you have learned with the assiduous team, what I want you to do is this. Every time you find the components of a vector, try to see where that vector is appearing on the on the Cartesian plane. How do you do that? Just look at the signs of the x value. Can you see that x value is positive? The y value is negative. So anyone that can help. In which quadrant do you see the x value being negative, the x value being positive, and the y value being negative? Anyone? X value, this is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth. Where is x? Remember, this is the positive x, this is the negative x, this is the positive y, this is the negative y. So where do you see x being positive, y being negative? In which quadrant? Severus? It's the fourth quadrant. Very good. So this is telling you that this vector is going to fall in this quadrant. That is vector D3. If you don't do this, it will be a bit complicated for you. All right. So every angle that you find after pressing tan inverse on the calculator is related to the x-axis. What do I mean? So if this is your Cartesian plane, if your vector is here, the angle that you find after pressing tan inverse is related to the x. It means it's this angle. If your vector is here, it is this angle. If your vector is here, it is this angle. If your vector is here, it is this angle. It should always be related to this line, not this one. This is the y-axis, not that. Okay, not that. That is going to be important for to help you find answers. So this angle that we have found is actually this one, 6.4. I can just put it here. The question is, why is the answer negative? It's because we are going in this direction. Remember what I said? I said that all angles go in this direction. If you go in that direction, the answer will be negative. That's why this angle is negative. So you need to find now the positive version of this angle. How do you do that? All you do is you want to move from this point, go like this, come back to this point where the vector is. So all you do is get 3 schist, remove this angle that you have found. Okay, just as simple as that. As simple as that. In other ways, to this negative angle, just add the 3 schist. As simple as that. So if you do that, what you are going to find is going to be 353.6 degrees. Let's confirm if these answers are correct. 355 meters and 353.6. Can you see that? It's because we've been rounding off. That's why we've written 353.6. V8 is 353.5, but it's still correct. There's nothing wrong. Does that make sense? Is there anyone that has got a question? Okay, let's continue with questions. We see if you are getting it. They've told us find the direction and the magnitude of vector sum if you add a plus b. And they've given us this is vector A, this is vector B. So I want to find the sum. You know what you do for this one? I've told you guys already, for every vector that you deal with, first write vector, and then write x component, and then write y component. As simple as that. So starting with the vector, so we'll first get the vector A. How can we find the x component of A? The x component of A, we are going to call it AX. That is going to be equal to Since A is here, we first write what? The magnitude of A. The magnitude is 30. We said you use cos, right? Cos, the angle. But I've told you guys that the angle that you use should always be this angle from the negative, from the x-axis, positive x-axis, going in the clockwise to where the vector is. So you are interested in this angle, not the one that they've given you, but this angle. So how can you find this angle? You remember this is a straight line and then they've given you. So how can you find this angle? Anyone that can help? You see, very good. So simply say 180 minus 25. And that's the angle that we use. That will be 155. Therefore, this is going to be 30 cos 155, and it has given me negative 27.189. To find the y component, ay is also going to be 30, but use sine 155. So that is 30 sine 155, and that has given me 12.6785. Does this answer make sense? Here in this quadrant, the y value should be positive, the x value should be negative. This makes sense, okay? That because we have found the x value negative, y value is positive. That makes sense. Let's now find the vector b. So also come here, vector b. We'll find the x component of b. X component of b will be, the magnitude is 20, so that will be 20 cos the angle. But the angle that you've been given here is 20, which is this one. Remember, we're always interested in finding the angle moving in the anti-clockwise direction to where the vector is. You can see that. So since we've been given this as a 20, but we want this angle like this, how can we find this angle? N1? How can we find this one? Be free to open your mic and answer. Like you have a complete circle. They have given you that this gamma angle here is 20. How can you find the rest of the angle? Very good. So it will be 360 minus 20, and that will be 340. So that is going to be 20 cos 340, and that is going to give us 18.79385. And then by is also going to be 20, but sine 340. Okay, so 20 sine 340, that is going to give us negative 6.84. Does this make sense? Yes. Why? In the fourth quadrant where b is, x is positive while y is negative, so that makes sense. So answering now the first part of the question, which is I, want to find a plus b, which is the sum a plus b. Now, for you to find a plus b, you first need to find the x component of the sum, and then you find the y component of the sum, and then that's when you can do it. So let's first find the x component of a plus b. Simply get this is your a, okay? So the x component of a plus b is how? It is basically ax plus bx. So your ax is negative 27.189. Your bx is 18.79385. As simple as that. And the other thing you need to find is the same a plus b but the y components. So that would be ay plus by. Ay is 12.6785. By is negative 6.84. Let me start with this one, which is down. That is going to give us, this is going to give us a 5.838. If we add what's on top, negative 27.189, 189 plus 18.79385. That is going to give us 8 is actually a negative value, negative 8.39515. After finding these two guys, what do we do? Remember, because it's a vector, supposed to find this magnitude and direction. So how can we find the magnitude of a plus b? This is still part I, right? So the magnitude of a plus b is going to be, remember magnitude, you simply get a square root of the x component, you square it, plus the y component, you square it. So the x component we are from finding negative 8.39515, square that, plus the y component 5.838. You also square that, and this guy, you are square rooting it. So that would be the first answer, the negative 8.395 squared plus 5.838 squared, and then you square root the answer. That is going to give us 10.22. That is the magnitude. We also need to find the direction. Remember the direction we said is given by tan theta is equal to y over x. So if you want to remain with theta, is going to be tan inverse of y. The y value is what? The y value is 5.838. The x value is negative 8.39513. So we just punch these two. 5.838 divided by negative 8.39513. And then what we'll do is we'll take the tan inverse of the answer that we find. This has given me negative 89.3957. Remember what I told you? Every time you find a vector, find in which quadrant is this vector. How do you do that? Look at the sign of the x value. X value is negative, this one. Y value is positive. So which quadrant is that? Where x is negative, y is positive. It is the second quadrant. And I said that every angle that you find is always related to the x-axis. So the angle that we have found here is actually this one, and that is the 89.3. But the angle that we're interested is the one coming from the positive x. It's this one. So how can we find that? Simply get 180. You remove 89.3. Simply add 180 to this, because 180, negative 89 plus 180 is the same as saying 180 minus that answer. It's the same. So that is going to give us 90.6 degrees. So let's confirm if this is correct. So you can see this is 10.22. Yes, this is supposed to be 145.16. So what is wrong with this angle? So there is nothing about the angle. That should just be an error there. Okay, unless if I've gotten a wrong y value. It's 5.838. The x value is 8, negative 8. Let me just punch again, and then if I punch it is still the same, then it is just a typing error for the question. 8.398, 8.39513, and then we take the tan inverse of that answer. Okay, if we take the tan inverse, it has given me a different one again. It has given me 34.8148, and then we add 180 to that. It has given me 145.185. Is it the same now? Yes. So please just make sure as you also punch on the calculator, you double check your punching because sometimes you can miss some numbers. So this is the answer. Is there anyone that has got a question? Anyone that has got a question? So that is what you are going to, so for number 2 and number 3, I'll give you as a quiz for you to answer those. But what you simply do is, since it's a minus b, so you are going to get the x component of a, you remove the x component of b. Get the y component of a, you remove the y component of b. And then do the same, find the magnitude and the direction. For b minus a, you'd simply be starting with this one. Now you remove this one. You write this one, you remove this one on top. Does that make sense? Is that okay? Okay, so let's end here. I want you to do those questions you send me. I'll give you how many minutes? 20 minutes, since I've already answered majority of these things. So 20 minutes, please answer, you send the answers. Thank you so much. Let's end here for now.